So here's our first example. We are going to use partial products in the distributive property to calculate the product of 200 times 32 6/10. Does everyone have that written down? If not, we should make sure that happens. All right. So 200 times 32 6/10. So let's look at the word distributive property and partial products to kind of give us an idea of what we need to do. What word do I see nestled here in distributive? What verb? If I wanted to pass something out, I am doing what? I'm distributing. So I know that somewhere along the lines, using the distributive property, I'm going to pass out one of my numbers. And the number that I'm going to choose to pass out is my 200. So I can rewrite this as 200 times, whenever you have a number in front of parentheses, you're always multiplying, right? Then I'm going to break this 32 6/10 into the whole numbers. Then I'm going to have a second term, and then I'm going to have my decimal. So here's 32 plus 6/10. So whenever I'm distributing something, I'm passing out the number in front of my parentheses. So what I like to do, what helps me, is I draw an arrow. And that reminds me, hey, I'm passing out this number. I have to pass it out to the 32, and I have to pass it out to the 6/10. Is there an operation going on here between the 200 and the parentheses? There is one, but let's all recall that math people are lazy, right? We like writing things without spelling everything out piece by piece by piece by piece. The operation, as I've already said, was multiplication. So now I can rewrite this problem into some partial products. This becomes 200 times 32 plus 200 times 6/10. Now notice how both terms inside my parentheses received the 200. In other words, I passed them out to the distributive property. So now they're both being multiplied. Now I have to calculate this out to find a product here and a product here. And those two are parts of my total answer. So we're looking at the words to give us clues. Okay, so I could write this out standard form or standard algorithm and multiply like this, but I don't really want to. I want to use what I know about math to make my life easier. Most of you should recall that whenever you're multiplying numbers and you see zeros at the end, before I multiply, can't I just write those zeros? Yes, because 200 is just 100 times bigger than 2, right? So what's 2 times 100? 200. So I know if I make my final product 100 times bigger by adding 2 zeros, I'm going to be okay. So what is the 2 times 2? 4 question mark. All right, I know that this is like some super hardcore 6th grade math, but what's 2 times 3? 6. Okay, so I use what I know about multiplication to make this easier. Let me compare that to the standard algorithm. What's 2 times 0? 2 times 0. 2 times 2. Oh, okay, so there's my 400. That's my first partial product. Now I'm on my tens place. To show I'm on my tens place, I have to add a 0. 3 times 0. 3 times 0. 3 times 2. So there's some other partial products. Did I get the same answer? Okay, so let's use what I know about math to make this problem easier too. I see 200. It ends with 2 zeros. So I know that my answer gets to be 100 times bigger. How can I show my answer is 100 times bigger? Yes, Jose? Yes, I can. He said, Mr. Dahl, yes, I could move it, my decimal 2 points to the right. I can also just add 2 zeros. So however many zeros you have, just write it down there, and you'll be okay. Ray, are we paying attention? With me, man? Okay. So now what is 2 times 6? 2 times 6.
12.
All right. But I know that I don't have a 6, actually. I have 6/10, which is 10 times smaller than 6, right? So to show that my final product is 10 times smaller, I need to move my decimal 1 point over. Here's the tool that I gave you guys last year. When you do your multiplication, look at your decimal. You want to pretend that's a whole number, so I'm going to bounce this out one place. So now I'm basically pretending that I have 200 times 6. And then I found 1,200, right? But then at the end, I remember that, okay, I didn't actually have 6, I only had 6/10. So I counted the number of times I bounced it out, and then I bounced it back in 1 point. So here's a partial product, here's a partial product. I could stack them like this, and add, and carry, and do all that. Or I can just look at my place value. What is 0 plus 0 in my ones? 2 10s plus 0 10s. 2 10s. Oh my goodness, people. I just asked 2 plus 0, and no one said the right answer. Wake up. Think about this critically. Everyone can add 2 plus 0. I know you can. Engage. Now I have 100 plus 400. How many hundreds do I have? 500. 6,000 plus 0 thousands.
6,000.
6,000. Wonderful. We can do this. So I got the same answer, just looking at it place value by place value. In a testing situation, do you have time to write out all of this? Or can we use the tools that we have in our toolbox to make this a little bit more effective, a little bit more efficient?
Yes.
Well, I hope so. So again, I used the distributive property to pass out 200. I found partial products with the decimal. Before you multiply, pretend that you don't have it. Bounce it out, however many place values. When you're done, you find your product, you count however many bounces you had to do total, and you move the decimal back in that many places. During our number talks, I'll talk more about why that's effective. At this point, do we really need to be able to explain in minutia how it works? I don't think you guys care how it works. I think you just want the tool. Count the decimals, however many times you need to bounce it out, and once you're done, bounce it back in. Just because this is 10 times smaller means your answer is going to be 10 times smaller. That's what happens whenever we're bouncing in, bouncing out, doing all this crazy stuff with decimals. We're adjusting the place value.